right. Good morning, everyone. So, be honest, who is really needing their either bottle of water or coffee they are nursing right now? I would never. I would never need such a thing. All right. Looks like we're clear to start. Hello, everyone. Good morning. Hope you had a lovely time last night. Today we're going to talk about something very different. But first, hello. I am Sander van Beek. Sander van Beek in English. I personally really like this joke. Um, I appreciate the groans. Um, I'm a test consultant at Bartels, currently working for the Nederlandse Loterij, and if you're not Dutch, that means the Dutch lottery. And I'm working there as a test automation engineer. But this is not what we're talking about today. All slides will be shared immediately, in my case, at the end of the session. What are we going to talk about today? Well, we are going to talk today about getting started with security testing. We are not talking about, I cannot make you a security expert in 25 minutes. I'm sorry. I know you're disappointed right now, but it's just too big of a topic. We're talking about assisting security experts. We're not talking about hacking. I'm sorry. It's fun, but we're talking about hard targets, not human targets. So we're talking about machines. And we are talking about security of a application, your application, and not of an entire organization. Right? With all that out of the way, let's dive in. Security. Security, as we all know, is an act in defense. And that means that a gate like this is not good enough. Like, this gate will keep out honest people, but malicious people will just grab a four-wheel drive and go past it. Right? Instead, we are looking to make armor for our application. Ask Rick. He was the knight last night. And the annoying thing is that our armor is only as strong as the weakest point, the weakest ring in this case. Because our attackers are sentient and they will attack the weakest spot every time. Speaking of the attackers, who are they? Well, they're actually, in the security community, they give three categories. The first ones are the white hat hackers. These are the ethical folk. They are, for example, security experts. If they find a bug, they report it with the sole purpose of having it fixed. They hack to fix stuff. On the other end of the spectrum, we have the black hats. These are the bad guys. These are the enemies. These are the villains. These are the persons you'll find in a Hollywood movie. They are in it for themselves, and we'll talk about what they want in a little bit. And in the middle, there is the gray hats. Now, this is a spectrum, right? The spectrum from all white to all black and everything in between. These are the opportunists. They're sometimes white, sometimes black. Like, maybe if they find a list of credit card numbers that they can exploit, they will first do a few groceries because they earned it. They have to pay their bills, right? But then they will report the vulnerability for fixing it. Today we're going to assume that everyone is a black hat because they are the villains and that's just easier to think about. So what do they want? Well, they have a few end goals. For example, they want money. They want to make money and they do that through ransomware, for example. Everything's encrypted, pay me Bitcoin and I'll decrypt it for you. Sometimes they just want data. That can be data to sell, but that would be money. Sometimes they just want data for data's sake. For example, personal data. A great example of these kind of hackers is government hackers. They hack other countries just to get the data. And then we have the making you suffer. For example, that one time that hacker group, collective, loose group of people, anonymous, took on the Church of Scientology because they did not agree with their views. So they were essentially bullying them through hacking. And the final one is the thrill, the I am better than you, I am the king of the hill, I got you. However, we cannot defend against these goals. This is super annoying. Can you please test if they can get money? Awesome. No, it's the intermediary goals that are much more interesting, because no matter the end goal, they all need some intermediary goals. And those are knowing how your system works, collecting data, sometimes that's the end goal, but sometimes that's just an intermediary goal, and to run their code on your machine. If they manage that, you are probably screwed. Okay, so these are things we can defend against, but how? Where do we start? Security testing is huge. It's a huge topic, right? There's a big library of resources and things you can learn. So let's go to the section of the library called OWASP. OWASP is, of course, the Open Worldwide Application Security Project. This is a non-profit foundation, and their goal is to improve security of software in the broadest sense. They have all kinds of resources, resources related to secure design, secure development, security testing, all that kind of stuff. But the resource we care about most today is the OWASP Top 10. These are the 10 most common security vulnerabilities in production, in the real world. And this top 10, there are 10, of course, I divided them up into 4 categories to make it a little bit easier to digest. First one is attackers can run their code on your machine. Attackers can get information on your system or data. The non-code attack vectors, not every vulnerability is because of code. And you cannot detect attacks, but we are going to skip that today. I'm sorry. I will be able to cover some, so let's dive in quickly so we can cover as many as possible. First off, first category, they running code on your machine. In this category, we have A03 2021. That means it is number 3 on the OWASP Top 10 of 2021, which is the latest version. This is excuse me. This is injection. And an injection is essentially the injection of malicious code into the application's runtime. There are many forms of injection attacks, like it all depends on the technology. SQL, NoSQL, whatever, it all doesn't matter. There are many forms of injection attack. If there's a technology that can be exploited, there's probably an injection attack for it. But practically speaking, it's easier to think about it in 2 categories: server-side injection and client-side. Server-side is about injecting malicious code into the application's runtime, that is your backend. And client-side is about injecting it into the user's runtime, that is your front end, and it runs on your user's machine. For example, welcome to Amazon. Not sure if you heard of the website, but they sell stuff. I searched for amazing. I did that over here. And why is this interesting? Well, this is interesting because my input, the input I control, also shows up on screen in these places. It shows up in the title of the page, all the way at the top. We don't really care about that, not a lot you can do there. But it also shows up in the URL, which means that if this were not just a keyword, but some injection code, I could send it to people. And they click the link, and the code is executed. This is why your security department does not want you to click malicious links or unknown links. It's because of these kinds of attacks. And finally, it shows up on screen. So, what if this code was, instead of amazing, a little bit of JavaScript or HTML? Would it be shown as HTML? Would the JavaScript be executed? If yes, that's bad. You don't want that. But at the same time, my query is sent to the backend. Maybe the backend runs on an SQL server. So what if that? What if? I'll just let XKCD speak for itself. So the pertinent thing in this comic for us here is this bit. Did you really name your son Robert Drop Table Students? Anyone knows that what drop tables does? Yes? This is an injection attack. They closed off the query with the quotation and then continued on. So what can we do about these attacks? We can validate user input, and if anything feels out of place, just straight up reject it. Sure, it's a good way of doing that, but it's not a blanket solution. The blanket solution is to sanitize user input. What does that mean? Imagine I searched for this. H1 amazing, a little bit of HTML. If this showed up on the Amazon page like that, it's bad. This was now executed as HTML. It was run as such, which also means I can craft a JavaScript message here. I don't have to know how to craft a JavaScript message to know that it is not sanitized. What I do want to happen is I want that to be turned into the this string and show up like that. This is just a way of encoding special characters in HTML. That's all it is. So this is what you need to stop a cross-site scripting, a JavaScript injection attack. And the details here differ per technology, but there are great resources out there to show you what exactly you need to sanitize. So what can we test for as testers that are not experts? We can test for the sanitization of form inputs. Are all my form inputs treated properly? We can look at the API inputs, because the API used by the front end is public, always. And we can sanitize the front end URLs, so that if an attack can happen, it cannot be sent to another person. And finally, file uploads. File uploads are one of the most scary things you can do. If you can get away with it, don't allow file uploads. If you need to, restrict it as much as possible. Restrict everything out of it. That is injection. At the bottom here, and the slides will be shared, don't worry, there's a cheat sheet. And these cheat sheet series give you all kinds of resources for developers, for testers, for all kinds of things. It also lists what to sanitize per technology. Now I want to talk about vulnerable and outdated components, number 6 in the list. And we already started with XKCD. Let's continue that trend. This is how software works, right? All infrastructure is based on top of other infrastructure, including that little bit that some random person in Nebraska has been thanklessly maintaining. And this also always reminds me of the quote in science, we stand on the shoulders of giants. We don't build everything ourselves. We build on top of the work of others. So this is how this works in practice. I grabbed an NPM package. This NPM, that's a Node.js package. It's called HTTP server. It has 13 dependencies. It's a very simple command line HTTP server. If I actually show you, hey, which dependencies do you have? It is this list. Basic auth, chalk, etc., etc., etc. If you ship HTTP server, you also ship these things. Now, tell me, are all of them secure? Are all of them up to date? Maybe some are end of life. They're all open source, right? So have hackers injected a backdoor in one of these? It happens all the time. And it gets worse, because if I run this command instead, I also get the dependencies of the dependencies. Because chalk depends on ANSI styles, which depends on color convert, which depends on color name. Are all of them secure? It's a big problem. But there's a thing we can actually test for here. That does not go through everything, but because that's unreasonable. What we can do is we can check for outdated dependencies. There are plenty of tools to help with this, thankfully. We can also check for the dependencies with known vulnerabilities. I just only talked about dependencies you ship, but this also works for infrastructure. So do you have outdated infrastructure? Or infrastructure with known vulnerabilities? The cheat sheet here lists an up-to-date list of tools you can use to automatically check this stuff. There are repositories of known vulnerabilities, and you can just check against that. That is attackers running code on your machine. How about them getting information? Starting with the number 1 in the list, it is broken access control. This is about users that can act outside of their intended permissions for whatever reason. For example, a user can see data intended for their supervisor. An employee can see their own customer data. An article is made public too soon. I would never do that. Our page is obscured but not secured. If you know the URL, you can get to it, but the URL is not posted. And much, much more. I really like this example. Missouri Governor Mike Parson is threatening legal action against a reporter and newspaper that found a security vulnerability and left a teacher and educational staff's social security number exposed and easily accessible. What scoundrels, they hacked the system. They got the one thing you need in America to steal someone's identity. They did that, and they told the whole world that they could do it. And they had to do a lot of things. No, they just had to click view source. It was in the HTML of every page. This is a really good example of broken access control. That should never have been sent. At this point, you may be wondering, access control versus GDPR? It's a dog-tail situation. Every dog has a tail, not every tail has a dog. You always need access control for GDPR, but not all access control is because of GDPR. Sometimes it's just company secrets, for example. So what can we test for? We can test for, can I access things without a login? Can I access things with the wrong login? And can I expose unlisted data by changing the URLs? And we have a definite advantage here because we already know the URLs, because we work on the system. For us here as not experts, don't go too far with this, right? But some basic checks can really help expose the big issues. That's broken access control. 2 cheat sheets here, the authorization cheat sheet. I like the other one, the insecure direct object reference prevention cheat sheet. That is a fancy term for change the URL and see if something's there. That's what we're talking about, attackers getting information. Then, non-code attack vectors. In this category, we're going to talk about security misconfiguration. This is secure design, secure tools, but insecure configuration. For example, I need a database. I need a database for my application, so I pick a Postgres database. Awesome, good choice, nothing wrong with that. But please, change the default username and password. Or to keep it a bit more technical, I have a server. It's a web server, it serves web pages. Because of that, I have port 443 open. That is the HTTPS port. That is good, that is fine, nothing wrong with that. But I only want HTTPS, so why is the HTTP port open? Why is FTP or SSH? Close all of the ports you don't want to expose. And there's much, much more, of course. Software is very configurable, and now everything runs in the cloud. It is even more configurable than it was before, which is good. It's nice and flexible, but it also gives you a lot of opportunities to create insecure configuration. So how to mitigate this? First off, simplify your infrastructure as much as possible. Just less surface area to attack is better. Use infrastructure as code. This means that you have to explicitly write down all the configurations you have for a system. This makes your infrastructure actually reviewable and checkable by either you or a security expert or whatever. And if you have the security as code, you can also periodically review or let someone else review your configuration. Another thing we do as testers though, right? Just make sure the devs do. Infrastructure as code cheat sheet, Docker security cheat sheet. Docker is often used and can be very annoying to get right. That is the non-code attack vectors. So, we covered some parts of the top 10 today. These ones specifically. We did injection, vulnerable, outdated components. We did broken access control. We did the security misconfiguration. Sadly, we did not do this one. We only had 25 minutes, right? So what are the bits we can actually test for as not experts? That is these ones. Injection, vulnerable, outdated components, and broken access control. So what do we test for in that situation? We can test for user input sanitization. That is in the GUI, that is in the API, and that is in URLs. We can test for broken access control with an account, without an account. Make sure you can access only the right things. And we can look at outdated dependencies. This is the I want to take a picture list if you want to. There are also some things we shouldn't test, but instead discuss with our developers or teams or whatever. Was I too quick? Yeah, okay. From the ones we discussed today, it's these two. The dependencies, the vulnerable outdated components, and the security misconfiguration. If you're talking with this about this with your developers, talk about reducing dependencies, talk about subscribing to vulnerability alerts, make sure they remove secrets from their code, no API keys, no passwords, and secure the runtime configuration. Cool. But we're testers. What about test automation? Test automation is also code, or often it is, right? And code should be secured, so test automation should be secure too, right? Is that even useful? I think it is. I think, yes, it is useful for one very specific reason. Security is an act of defense. If you ever mess up, you are not happy. Because of that, it is a very good idea to make security a habit, even in situations where it might not strictly be necessary. If you make it a habit, you're less likely to slip up. Also, remember the intermediary goals of the attackers. How does your system work? And running their code on your machine can also happen on a test environment. I am going to assume that you do not have production data in your test environments, so collecting data is out. If you just felt called out, it's all three. So when we look at test automation and security, we can think about things like reducing our dependencies, about subscribing to vulnerability alerts, dependency vulnerability alerts, remove our secrets from code, and secure the runtime configuration. That's the same list. So the things we can do for test automation are also the things we want to do for our production application. So if you're doing it anyway, just do it twice, right? And this all comes down to that mantra to make security a habit. In summary, security is an act of defense. The attackers will attack your weakest spot, always. One slip up and you're done. There are 3 types of hackers: the white hats, the gray hats, the black hats. We talked about part of the OWASP top 10, specifically these parts. And these are the things you can test for: the user input sanitization, the broken access control, and the outdated dependencies. This is the list of stuff to discuss with your developers. But above all, if you only take away one thing from today, it is to make security a habit in your team. So, what will you test next week? And do you have any questions?